Hello, this is the final video for our game. This is Dave Castillo, Alex Burkout, and Jonathan Holdway. Our game is the Guitar Hero Replica, and when you first open the project, first program your board, before you do that, you gotta make sure that this rightmost switch is in the on position. That is the power switch, and it's just better to have this on beforehand because then the picture shows up and that's how you know you're doing it right. But if you take this switch, put it in down position, it goes down. If you put it back up, game comes on again. And these lights correspond to which block the notes are coming into. And these buttons correspond to these blocks right here, which are like the user stationary blocks. These are the moving blocks coming down. So the goal is to hit the button right when the note is over the stationary block. And then it will count your score. Once your score goes up and you have a combo will go up. And the combo is how many points you get per note you hit. So it only goes up to 9. So if you get a note correct, the score will go up by 9. And I'm going to play right now. See if the score goes up. Also, a fun little thing is that these two leftmost switches actually control the speed at which notes go. So I'm going to do it at various speeds just to show you. Here's fast. It's a little bit slower. And then here's both of them up, which is probably the hardest setting. And if you miss a note, your combo goes down, your multiplier goes down. This is a multiplier and combo. So this is our game.
So now that you've seen a bit of how our game is operated, I'm going to go over about how it was implemented. Our top level component takes in a 50 megahertz clock. It takes in 4 push buttons. It takes in a power switch, and it takes in 2 switches for setting the difficulty. We use several LEDs just for debugging purposes, and then we have a bunch of signals that we use to drive the VGA component. The top level design of our project is mainly just component instantiations, but it does have a couple processes that I'll talk about quickly. It has a process for updating the score, so every time we get a new score instance variable on the rising edge of the clock, we will just update our total score by adding the score instance to our current score. We also have a process that we use to control the difficulty. Based on the value of our difficulty switches, we will change our difficulty constant. This difficulty constant is using the time constant for setting our game clock through a clock divider. Our input are available for 100 ticks, so we need a process for tracking when those 100 ticks expire. So we have this timeout variable, and we just count up to the timeout. Once the timeout's hit, we want to trigger the expiration condition, which means we need to move on to the next input. And then we have a queue of input variables with our previous input, our current input, and then the next 4 inputs, and we will shift all those up 1 in the queue. The main process for implementing the logic of the game is this input handler. It takes in the 4 push button inputs, and we'll check them against the current input that you would expect, and it will output your combo increase and your score update. The first process in this component is essentially just the state tracker, so it'll shift the next state to the current state, and it will update the received input based on the buttons the user pushes. We also have a process that we use for tracking the current combo. Essentially, when there's a success, we want to queue up a combo increase. If there's a fail, we want to queue up a combo decrease. And then on the rising edge of the clock, if we update the combo and we have room to increase it, we'll update it by 1. Otherwise, if we hit our cap of 9, it'll stay the same. And if we need to reset it back to 1, we will do so. This next process is the one that actually handles the next state logic and the output logic. It has 2 states, the waiting input state and the validating state. In the waiting input state, we're waiting for the user to hit a button. So if we hit this expired condition, that means the user has not hit a button in time, which means we want to queue up a failure, and the score doesn't go up at all. If we receive all 0s, this means the user hasn't hit a button yet, so we'll continue waiting for an input. And otherwise, this means the user has hit a button, which means we want to move to the validating input state. And we want to check if the received input is equal to the expected input. If it is, this is a success. The user hit the right button. And we want to output our score to update by the combo value, so we will return combo there. Otherwise, this means the users hit the wrong thing, so we want to say that the user failed their input, and we don't want to update it all. In our validating input state, essentially all this does is hold. So if we haven't hit the expired condition, that means the input is not ready yet, so we'll keep awaiting in this validating input state. And then once the expired condition is hit, we will go back to the waiting input state so we can validate the next input. In this draw component, we have the main logic for drawing our game, everything except the scoreboard. We essentially have two processes in this component. We have the animation process and the draw process. In the animation process, we track the vertical position, which is the start of each of the falling boxes for each input that we want to display. If we hit the expired condition, then we just reset each box to its initial position. Otherwise, on the rising edge of this animation clock, which is synced up to your game speed, we want to increase the position of the box by 1, which essentially moves it down the screen by 1. In our main draw process, this is what we use for actually determining whether we want to draw a box or not. We check the current vertical position against the vertical position of the box and the vertical position of the box plus 50, because 50 is the height of our box. If it falls within this range, that means we might want to draw a box here. So we will call this horizontal RGB function, which does a similar thing to checking the vertical position, except it checks the horizontal positions, and then it validates whether the current input falls in the column for each horizontal box. So if it falls in the first column, it'll draw the box in the first column. But if our input's 4, it'll draw the box in the last column. We can repeat this process for the next 4 inputs. The only case where this is different is for the expected box, because we also want to draw the white hit zone boxes. We have another function here called drawExpected, which draws the falling box for the current input, as well as also drawing the white boxes for the hit zone so that they don't get overwritten. Finally, for the input on the way out, we can do a similar thing as we did for the input on the way in, and just call this horizontal RGB function for the input on the way out. Hopefully this gives you a better idea of the main logic for implementing our game.